Good evening, everyone. Welcome to our session with respect to geography. Let's continue our classes. Just give me a minute. Yes, last day we discussed about previous year questions with respect to prelims examination, and we have seen around 12 questions and the ways to solve this with knowledge, without knowledge, intelligent guess, educational guess, everything we have seen. Today, we will be seeing, and we also discussed about the structure of atmosphere last day, what it composed of everything. Today, we'll deal the same topic, but little more advanced thing. Today, in detail, I'll tell you what is the structure of atmosphere and how everything, the structure like troposphere, stratosphere, all this structure, because all these things, areas are important with respect to prelims and mains. In mains, there are questions which comes directly asking about structure of atmosphere the previous year. So you should be having a ready-made answer for the same. And in prelims, as you can expect n number of questions from this area, because all these statements, all these words, all these jargons are very important with regards to prelims. Okay, so just start. Structure of atmosphere. You can keep writing the notes with me. See, basically, you now know what are the contents in atmosphere, gases, water vapor, dust particles are there in the atmosphere. We have little idea about all these things. So in detail, when we are looking at the structure of atmosphere actually consists of different layers with varying density and temperature. Okay, so density is always highest near the surface of the earth and decreases with increasing altitude. Okay, I'll explain to you what is this. If this is the surface of the earth, okay, and which increase in height, we say it as altitude. Okay, with increase in altitude, there is decrease in density. Or easy way to understand this concept very clearly is that towards the earth's surface, okay, towards the below portion, if you're looking from top, towards the below portion, the density is more. Okay. This you can also remember in another way, thinking that the particles which are denser, particles which are heavy will always like to settle down, right? So the denser materials will always come towards the earth's surface. Because of that, we can say with increase in altitude, when you are going up in the atmosphere, density will decrease. When you're coming down towards the surface of the earth, and density will increase. This is the concept. Okay, so density, where is density higher in the atmosphere? Density is higher near the surface of the earth. Here you have maximum denser particles coming to the surface of the earth here. So this you should be very clear. So where are the particles which are denser situated in the atmosphere? Denser particles are towards the surface of the atmosphere. Okay. Then there are different layers in the atmosphere. We have troposphere, stratosphere, mesosphere, thermosphere, exosphere. Different layers are there. Basically, these layers are differentiated, or different layers exist because of the temperature conditions. Okay, that is the first criteria you should be knowing. What is the basis of this differentiation? Temperature. Because of temperature differentiation or temperature criteria, all these layers are made. Okay, and the first lower layer is called, I will make a, okay, if suppose this is the earth surface, the layer immediately above the earth surface or touching the earth surface, and this layer is called stratosphere. Sorry, troposphere. Sorry, troposphere. Okay, so troposphere is the layer which is above the earth surface. So troposphere is the lowermost layer when you are seeing in the atmosphere. It actually, okay, important thing with regards to troposphere you have to remember is that there is a question always comes regards to why this equatorial area is so long and polar regions are very short. Can you see the difference? Okay, it is like I have drawn it purposefully to show you the difference. Equatorial area, you can see it is height is so much, and towards the, it is almost like 18 kilometers, and polar area is only 8 kilometers of the troposphere. So why this differentiation is there? Okay, thickness of the troposphere is greatest at the equator because heat is transported to great heights in the equator. Equatorial area, you have a lot of water bodies are there, oceans are there, seas are there. Because of that, evaporation happens. This we discussed yesterday. Because ocean area is more towards the equatorial area, and because of that, evaporation happens. Heat is produced more in that area, so their space is required. Okay, heights are required to get transported all this water vapor up. Because of that, this area is so big or so lengthy we can say. Okay, but when you come to polar regions, you know that evaporation is very less, and whatever dust particles or water vapor content is very less, so it is not required to move so height. Because of that, polar regions are very short. Okay, only 8 kilometers here, because there's a separate question, possibility of asking a separate question with this troposphere itself, why there's a difference between equator and polar regions. Okay, in NCERT it is given, but I don't know if it is given so clearly why it is come like that. Questions are there in test series, different test series I have seen. So this is a important knowledge you should be knowing. First thing, you should be knowing what are different layers, and each different layers there are some specific things you should be knowing. That is a thing. Okay. Now, troposphere discussed. The zone separating the troposphere from the stratosphere is called tropopause. Okay, we have something. This zone is there. This border line is there, and this is called tropopause. Tropopause. To see the word pause. What do you mean by the word pause? You when you're seeing some video, what will you do? You pause it. If you want to talk in between or we move around somewhere, you pause the video. That means what we are making is constant. Okay, tropopause means the temperature is constant here. Why temperature? Because all the differentiation in the Earth's atmosphere is based upon temperature. When temperature is constant here, we call the area as tropopause. Okay, so the temperature is constant. Obviously, temperature will be different near equator, different will the pole. That you know that. When it comes to the pole, temperature is more there, almost around minus 45 degrees Celsius towards the pole, and towards the equator it is only minus 80 degrees Celsius. Okay, so that difference is there. So because temperature is constant, we say that area is tropopause. Okay. Now about troposphere, another layer, and that is called stratosphere. Stratosphere. In NCERT, there's a separate picture given. Maybe I don't know if it is easy to understand. Because of that, I have made a picture like this. It will be easy for you for your understanding. I think seeing this picture, you will be having an idea from Earth. If this is Earth, from Earth's surface, different layers are there. I think it will be easy for you. Okay. Now coming to stratosphere. Stratosphere is found above the tropopause and extends up to a height of, I think, 50 kilometers. Okay. This we said around 18 kilometers, and this is actually from the surface. This is surface of the Earth. From here, 50 kilometers. We have stratosphere. Okay. And one of the important feature of stratosphere is that it contains ozone layer. Important feature, ozone layer. About ozone molecule we discussed yesterday. I told you that ozone layer is there, and whatever incoming solar radiation is there, ozone layer is filtering all the ultraviolet radiations. It is not allowing it to pass through. It acts as opaque thing, and only rays which are healthier for human beings and living organisms, or whatever healthier for biosphere, is only passing through the layers. Okay, this I've told you yesterday, and we have seen a little bit information also. Okay, so the layer actually absorbs ultraviolet radiations and shield life on the Earth from intense harmful form of energy. I'm not going in detail because I have given you a little introduction yesterday. I hope this will help you today. Okay, you got an idea. Then above stratosphere, we have another layer called mesosphere. Okay, so troposphere, stratosphere, mesosphere. Mesosphere is actually 80 kilometers from the Earth's surface. 80 kilometers. About 80 kilometers. And okay, I want to talk about the temperature also in all these layers. Let me talk. Okay, see, I told you we have this differentiation because of the temperature differences. And normally what happens? Normally from the Earth's surface, when you go, altitude increases. Altitude means height. Height increases, temperature decreases. Normally you will see in all the layers. But there are situations, situations that sometimes what happens is that because of the presence of some particles, some layers, some different things. Temperature difference will be there. Temperature may increase. That I'm going to talk here. Okay. First layer is troposphere. This we are discussing. Troposphere, I told you, with increase in height, there is decrease in temperature. As usual, normal thing. Okay. And this concept is called the lapse rate, normal lapse rate. We'll discuss about in some time. I think within 5 minutes, I'll be talking about that. No, don't worry. You understand only this much, that increase in height, there's decrease in temperature. When you go up, temperature is less, you will feel cold. Okay. That is a commonsensical thing. Then second layer is stratosphere. But stratosphere, it is supposed to be like again increase 50 kilometers is going up. So you have to have more colder temperature there or colder degrees there. But what is happening is because of the presence of ozone layer, temperature actually increases because ozone absorbs all these things. It becomes very hot and temperature increases. Okay. And mesosphere, there is no differentiation, there is no layer, there is nothing special here. Because of that, what will happen? Temperature again decreases. Alternate thing. Here temperature decreases, here increases, again it is decreases. And the last thing, the last layer which I want to talk here is thermosphere. And above it you have exosphere. Okay. With regards to thermosphere, thermosphere is actually around 80 to 400 kilometers from the mesopause. Okay, the border line is called mesopause. I don't have to tell you especially what it is. And importance of thermospheres, you see, thermosphere has something called ionosphere. Ions are present that will help in the radio communication, everything from the Earth's surface. Because of that, what happens is that again temperature variations are there. I told you something special present. What will happen? Temperature will increase. Temperature increase. Okay. So it is easy to remember alternate thing. First thing, temperature decrease, then temperature increase. Then again decrease, then increase. Okay. And wherever increase is there, you have to remember that some extra is there in that layer. With regards to stratosphere, ozone is the extra thing. With regards to thermosphere, ionosphere is the extra thing. These are the different layers of the atmosphere. I think easy to understand. Different words you have to remember. And this is a picture which you can copy in your notes. Easy to go. At one look, you will get the information what it is. Okay. So that's the thing about the structure of atmosphere. Then I want to talk about insolation. Okay, solar radiation. Yesterday we discussed about incoming solar radiation, outgoing terrestrial radiation. So in detail, little I want to talk about insolation. Insolation means incoming solar radiation. Little we talk about that, and then also talk about how insolation is different in different places, because there are a lot of MCQs I'm seeing, and also in previous year UPSC questions I'm seeing there are multiple choice questions, including what are the questions like what are the factors that is causing variations in insolation, or what are the factors affecting temperature of a place. Okay, all these questions are coming. We will throw a light on that, and then we'll have a little discussion on that. Okay, then we'll discuss about heat budget of the Earth. Okay, so I'm erasing this. This is something called incoming solar radiation. Incoming solar radiation is called insolation. Okay, insolation. Okay, incoming solar radiation is called insolation. So this word is come from this. Okay, so Earth's surface receives most of its energy from short waves. Yesterday I have drawn a picture also that short wave is coming towards the Earth's surface. Like this we have drawn. Okay, if you remember. So these are the incoming solar radiation. So Earth is receiving most of the energy in short wavelength. Okay, the energy received by this Earth is known as incoming solar radiation, which in short we call it as insolation. So from now onwards, I'll be talking only about insolation. So you should be keeping in mind insolation means incoming solar radiation is what I'm talking. Okay, fine. next thing I want to talk here is, there is two situations with regards to sun and earth, that is called perihelion and aphelion. Okay, what is perihelion, aphelion? Because with including dates, questions are being asked in all the test series and the UPSC question papers. So a little bit we'll discuss about that. Okay, see, solar energy we are receiving from the sun towards the earth varies at different places. Okay, we'll also see why it is varying, because from the sun we know that earth is far away from sun. Whatever energy received from the sun, it is not falling on earth uniformly. Sorry, it is actually falling on the earth in different places differently. The earth rays or the sun rays, which is classification name, I'm talking about two situations between sun and the earth. Okay, two situations are perihelion and aphelion. I'll tell you what is perihelion and what is aphelion. These are the two situations that occur in January of every year and July of every year. But practically you will not feel any difference. We will not feel any difference. But theoretically you should be knowing these situations. Okay, what is perihelion? What is aphelion? First, we'll talk about what is perihelion. Perihelion is actually on 3rd Jan every year. Earth becomes so close to sun, and this position is called perihelion. Okay, perihelion means close to sun, closest to the sun. And you have to remember the date also, 3rd Jan. Questions have been asked for the dates, 3rd Jan. Okay, I'll tell you trick to remember. We'll talk about aphelion. Okay, aphelion is actually, so if it is closest means aphelion means what? What actually so far, or the farthest position. That is called aphelion. Farthest position from sun. Okay, and that is around 4th July. The trick to remember is that when you are so close, starting of the year, and slowly when you are going far, middle of the year, 4th July. Okay, by this concept you can remember. So I'll repeat what we're discussing here. We're discussing about during the revolution of earth around the sun, earth is farthest from the sun and earth is closest to the sun at two different points, and two situations are there where earth is so close, and this is called perihelion, and earth is so far from the earth, maximum far it can go. That situation is called aphelion, and the date of perihelion, that means so close, 3rd January, and goes away in 4th July. Okay, and but the problem is that, or it is not a problem, it is a very good thing. Effect of this variation in the solar output is actually covered by distribution of land and sea and the atmospheric circulation, because there is a distribution of land and sea in the earth and atmospheric circulation. Because of all these factors, we basically don't feel the difference. We basically don't feel that on Jan we are so close to sun, and in July we are going far away from sun. We don't feel all these things. That's actually a blessing. Otherwise, it would have been affecting our day-to-day life. Okay, that feeling will not come. But scientifically, this is a fact, and you should be knowing this. Okay, then we'll discuss about something called, I am thinking that this is okay with you. This perihelion, aphelion, and insolation concept. Three things we discussed here. I have spoken about insolation, perihelion, aphelion. What is insolation? Incoming solar radiation in the form of short wavelengths are called insolation. And when sun is very close to the earth, or when earth is very close to sun, on 3rd January we call situation as perihelion, and it is very far. On 4th July, situation is called aphelion. Okay, it's a very simple concept, but it may get confused when asked in the question different way. You should be only conceptual clarity is required in geography. See, geography, important thing to be, once you know the concept, you are done. Then you don't have to revise every time. Of course, for examination point of view, you have to revise each and every statement what's in notebook. That is different things, NCERT books. I'm telling about the conceptual wise. Once you know the concept, once you know how a volcano is forming, once you know how earthquake happen, once you know how hurricane is happening or cyclone is happening, once you know the concept, you're done with geography. Okay, you are good. Then only you have to revise the certain points like this. What is perihelion, aphelion, insolation, all these concepts you have to revise. Okay, That's a good thing with geography. You invest time in geography, you know the concept, you try to learn things, and you're done with the chapter. Okay, that's the thing. Okay, next thing we'll discuss about incoming solar radiation insolation. We said actually this variability of insolation is there at the surface of the earth. Different surface at the point of the earth surface, the insolation amount is different. I mean to say that if this is earth, okay, and this is sun, whatever rays coming here and whatever rays going here is different. Okay, that effect is different, and about this effect we'll talk now. Okay, the amount and intensity of insolation vary during a day, in a season, in a year, anytime it will keep on varying, because you know that earth is moving like this. Earth is moving, because of that the rays which is falling will be different. Okay, it will be different, because of that it will change. The factors that cause these variations in insolation are different factors are there, that we'll see now in detail. Okay, you can write the heading like this: factors causing variations in insolation. Factors causing variations in insolation. Okay, different factors there. One by one we'll write it and we'll discuss. Okay, first one is because of the rotation of earth on its axis. Rotation of earth on its axis. Each and every word is important here, because all these lines are a possible question. And geography, if you know the concept, you can mark the answers very quickly and move on to other questions. And if you're confused with the concept, if you're not clear on what the question is, it will eat your times like anything. People have experienced, even I also have experienced that. So because we will having some idea, so we'll try to come to an answer and we'll keep on thinking, and it will eat your time. Okay, so don't do that mistake. Whatever you are studying, study it thoroughly. You're clear with that, and as soon as you get a question, you are a dancer. Okay, not wasting time. And geography, at a one stretch, you will get the answer if you know it. Okay, fine. Rotation of, because all these are phenomena. Okay, actually, what is happening? There's nothing to guess, nothing to worry about this. Okay, so first option is rotation of Earth on its axis. Okay, so what do you mean by this factor? See, Earth's axis make an angle actually 66. Earth axis is not. It is like this. Okay, it is like this. It is tilted position to the surface. If you're taking surface like this, it is like 66.5 degree tilted. It is not straight. It is not like this. It is not like this. It is not 90 degree. It is not like this. This is the position of Earth's axis is this, and it is rotating on axis in this tilted position. Okay, it is tilted. Tilted. Okay. See, this fact that Earth's axis makes an angle at 66.5 degree with the plane of its orbit around the sun, actually having a great influence on the insolation, because it is tilted. The rays coming from the sun towards this Earth will be different. For example, if sun is here and rays is coming, to see how it is varying, it is going up, and to this polar area you have to go so far. By the time this rays reaches here, that effect of heat will be very less, and still you feel cold there. Okay, and in equatorial areas it will reach fast. Not even equator, it is below the equator. The equator is here. So if the Earth is in this position, the variations are different. That is why I told you the Earth's axis, how the rotation of the Earth on its axis, it is actually a factor behind how insolation is coming. I hope that the word insolation, you are clear. Insolation is incoming solar radiation. So whatever rays coming from the sun, because of that, it is tilted. Earth is tilted. The effect on light or the light energy reaching the Earth's surface is different at different positions. Okay, that's the first thing. Now we'll do the second thing. Second factor is that angle of inclination of the sun's rays. Okay, this I have already discussed in this point. Angle of inclination of the sun's rays. Angle of inclination of the sun rays. The second factor that determines the amount of insolation received is the angle of inclination of the rays. Okay. So this is depending upon the latitude of the place. So you have Earth like this. You have tilted position like this, and you have equator tilted, and you have Tropic of Cancer at 33.5 degree north, and you have Tropic of Capricorn 33.5 degree. I hope you guys know all the basic things supposed to get from 6th standard, 7th standard NCERT of geography. You should be knowing this. Okay, 36. This is South Pole. This is North Pole. Okay, so this is a basic situation of how an imaginary Earth looks like. Okay, because of that, what we are talking about, the inclination of angle. I am saying the insolation basically depends upon the latitude of the place. If sun is here, I told you inclination of the angle because of which latitude you are living in. Suppose you are living in Canada, you will come somewhere here. Suppose you are living in Indonesia, Malaysia, you'll come. Suppose you are living in Australia, you'll come somewhere here. And because of the inclination of all these angles, temperature you will feel is different in different places. That is the main thing which I want to talk here. See, area covered by vertical rays is always less than the slant rays. Okay, if slant rays are more, the heat you experience is more. If the slanting is less, you will experience more heat. Okay, this is a concept with regards to angle of inclination of the sun's rays. Okay, why I'm discussing here, obviously you can read from your NCERT, but provided you should be knowing the concepts. Now you know all these concepts, you are at least clear about what is a basic thing. So when you read, it will be easy. Okay, and when you try to solve a question, it will be very easy because it is coming, you know the concept. Okay, and the third point which I want to discuss here is third factor which is affecting the insolation of an area is the length of the day. Okay, let me write down. Length of the day. See, in this, I actually wanted to draw a diagram, not a diagram, a tabular form. This I've taken from NCERT, nowhere new. So, length of the day in hours and minutes on winter and summer solstices in the northern hemisphere, a table is given there. So, I'll give a small example so that you should be, you should be clear. Okay. So, there is a column called latitude, winter, summer. We are talking about length of the day. Okay, winter, summer, how it will be. Okay, if latitude 0 degree means equator. Winter time 12 hours at the equator, and in summer time also 12 hours. Okay, then latitude 20 degree. 20 degree both north and south, you can imagine. Winter time, the day is actually reduced to 10 hours or 11 hours. Okay, and summer time it is like 13 hours. I'll explain. Latitude 40 degree, winter time, it is like, sorry, okay. Latitude 40 degree, winter time, it is actually 9 hours, and summer time, it is coming around 15 hours. Okay, I'll explain you this one. See, at different latitudes, how insolation is different, I'm showing. How it is affecting the length of the day. In winter, for example, you can see 0 degree equator we are seeing. In the equatorial place, equator where Singapore, Malaysia, all this Brunei, all these areas are situated, where sun rays is falling directly on the Earth's surface. The most insolation which that is falling is called that area, equatorial area. When at 0 degrees Celsius equator, we can see winter time and summer time, the length of the day is same, 12 hours, 12 hours. There is not much difference. You know that when you go to Indonesia, Thailand, Jakarta, all these places, even though it is December, even though it is June, the length of day and the night is same. You will not feel any difference. Even the climate is almost the same. You have rain every afternoon, and all these are expected things. Okay, apart from cyclones and all these things, the climate and the weather is almost expected the same. So there is not much change. When you go to 20 degree north and south, for example, northern hemisphere, if you are seeing 20 degree, you can imagine that winter time, the day is actually reduced to 10 or 11 hours. There is not 12 hours. And summer time, actually, it is more, 13 hours. More time is there. Okay. And 40 degrees is northern hemisphere. If you are seeing, winter is actually, that day is very, very less, and summer is more. Okay. This is this table, you can just draw it for your basic understanding. I want to show here how length of the day on winter and summer varies in the northern hemisphere. Okay, so basically what I would like to you guys to do is that after going through the session today, please go to NCERT class 11 and you can see the entire table there. I've taken only part of this and you'll have a clear look at what it is. Okay, fine. So you know now, because of the insolation or the incoming solar radiation, the variations in the length of the day also is affected. That factor you know now. Okay, now let's continue. Fourth factor. What is the fourth factor? Fourth factor is that, so first factor was rotation of the earth on its axis. Second factor, angle of inclination of the sun's rays. Third factor, length of the day. And fourth one is transparency of the atmosphere. Transparency of the atmosphere. How transparent the atmosphere is depending upon that how rays are reaching to the Earth's surface. It is very easy to understand. Suppose Earth is like this, okay, and you have atmosphere around the Earth, okay, and you have sun here. Rays are coming. Depending upon how transparent this atmosphere is, correct? If the atmosphere is so transparent, what will happen? It will allow all the particles to come in, all the rays to coming in. If it is so opaque, because so how this transparency will change? Because of pollution is one answer. Because of that pollution, because of dust particles are there, carbon dioxide emission is more, and because of that, and dust particles, if evolution happen and it mixes with water vapor, and all these things happen and become opaque. So it will not be so transparent for the suns from the or insolation to reach her. This is one factor. Okay. I want to talk two more things related to this point. That is the red color of the rising and setting of the sun and blue color of the sky. These are two questions, commonsensical questions. I am sure you guys will be knowing it, but I am just telling you here. See, there are suspended particles or what dust particles in the troposphere or the atmosphere. See, what happens is that when from sun rays falling on these particles, okay, sun rain falling on these particles on the Earth's atmosphere, there is scattering happens. Okay, the red color of the rising and the setting of the sun and the blue color of the sky are a result of scattering of light within the atmosphere. Because of that, all the scattering happen, and we will see the sunset and rise are red in color and the sky in blue color. Actually, it is not red, it is not blue. Only we are seeing because particles present in the atmosphere scattering in that way. Okay. So that is also a concept which I want to talk with respect to transparency of the atmosphere. Then we'll go ahead with the next factor. Next factor is configuration of land in terms of its aspect. Okay, configuration of land. See, in configuration of land, I want to tell one thing abruptly. Land and sea. Land, sea. Land gets heated and cooled fast. Sea will take time. This is the basic concept. You should be knowing this at any cost. Okay, from today onwards, you should be knowing this. There are two, only land and sea is in the atmosphere. We know that. If an area is not land, obviously the area is sea. There is nothing. There is no other third option. Land from the insolation or incoming solar radiation coming from the sun, as soon as it is hitting the land will get heated very, very quickly as compared to sea. Why? Because the density of the land comparatively at different places is very less, and it is like particles are closely packed. It is very easy to transfer the heat. Because of that, land get heated very quickly and it will get cooled also very quickly. But comparing to ocean or the sea or the water will take a lot of time for this insolation to get absorbed, reflect, and it will take some time. Because of that, anything you see from today, you should be clear that which one get heated fast, land will get heated fast. Okay, so configuration of land actually also plays an important role with regards to factors causing variations in insolation. Okay, I hope I'm clear in all these points. Okay, one more concept we'll discuss. We'll discuss something called maximum insolation, where it is coming. Okay. Okay. Maximum insolation. Because I'm talking about insolation, let's complete the topic entirely. Maximum insolation. So if this is sun and this is earth, okay, sun's rays are falling. So abruptly, when you see in the picture, what do you think? Maximum insolation is falling on the equator. Because of that, equator will be most heated. But it is not the fact. Okay, the fact is that maximum insolation is received over the subtropical deserts where the cloudness is least. Okay, so the key word is cloud. Okay, I told you equatorial area, you have a lot of water here. Okay, fortunately or unfortunately, we don't know where the equator passes through. The area is covered maximum by water, and the presence of land is very, very limited. Because of that, what happens? Lot of evaporation happens, and water vapor will be there in the atmosphere. Because of that, what will happen? The end is clouds are formed. Because clouds are formed, incoming solar, if this is cloud, incoming solar radiation is coming, it will not allow to pass through. Okay, it will keep it with itself, or sometimes it will reflect back also. Okay, this phenomena is called albedo of the earth. Albedo of the earth. Okay, what do you mean by albedo? Whatever incoming, I'll discuss in detail when we're discussing about heat budget, but for the time being, you understand, when incoming solar radiation is coming, there are white surfaces. For example, white surfaces. Okay, white surfaces like ice, snow, clouds, or white patches, anything that will reflect back whatever is coming. Okay, because of that, we will not experience lot of heat, because if lot of heat is coming from sun towards it exists in great heights if the ice is there. Okay, for example, great heights like Himalayan mountains and all, if ice is there, albedo is there. Whatever coming in, it will reflect back. Okay, so that's a fact. It also exists in heights. Don't get confused by thinking that it only exists in land area or in the cloud. It also exists in heights, only considering the fact that if some white reflecting patterns are there, not from the dark colors. Okay, and you know, in a summer when you go out, if you are wearing light colors, you will feel cool and relaxed, and if you're wearing a black shirt, it will be very difficult. Okay, so that you know the concept. Okay, we are deviating from the point. Coming back to the point, maximum insolation is actually happening where? Tropical deserts. Why tropical deserts? Because the cloudiness is less in tropical deserts. Let me write now. Maximum insolation is there in subtropical deserts. Desert is there is no availability of water, evaporation is not happening, water vapor is not moving up, cloudness is not there, so less cloud. Because of that, if there is less cloud, it will fall directly on this. Okay, here cloud is there, so it will get reflected back or only little bit going. Okay, and this is how the insolation, maximum insolation concept is there. I'll repeat, maximum insolation is received over the subtropical deserts where the cloud is least. Okay, equator actually receives comparatively less insolation than the tropics because of the effect of albedo and other factors. This is the thing. Okay, I hope this maximum insolation concept is clear. Now we'll move to the next topic. Okay, with this insolation, I want to discuss about three different main things, that is conduction, convection, advection. Okay, we'll discuss about this also relating to insolation only. Okay, let's see conduction, convection, advection. Okay, this three process we'll see. So actually you guys know all these things. Maybe if you're hearing this for the first time or repeatedly you've heard, the concept is very simple. Okay, we'll go through what it is. I told you earth is actually being heated by insolation. Okay, but that means incoming solar radiation is heating up the earth, and this transmits the heat to atmosphere near the earth in a long wave form. Okay, because suppose the earth surface is there, incoming solar radiation is coming to the earth is radiating back to us, long wave terrestrial radius we have seen. Okay, so the air in contact with the land gets heated slowly. So it is actually, which one is heating the atmosphere? Not this one. The long wave radiation is actually giving heat to the atmosphere. Because of that, this land which is near to this one will get heated fast. Okay, so don't think that water sunrise is coming, that is giving the energy. Of course, it is giving the energy, but what is heating the atmosphere? More effect is towards the long wave radiation, which is going from the Earth's surface. So the air in contact with the land gets heated slowly, and the upper layers in contact with the lower layers also get heated. For example, one upper layer is here, it will get heated. Okay, then it is going down, lower layer is getting heated, again it is getting heated. So heat is decreasing also when you're going up. Okay, we know that situation. So, and this process is called conduction. Okay, I'll repeat, conduction takes place when two bodies of unequal temperatures are in contact with one another. Okay, two bodies of unequal temperatures. Two bodies of unequal temperatures are in contact. That is how conduction takes place. It's actually transferring the heat from one body to another. One day-to-day example I can tell you. When you're making tea on a gas stove, suppose if you're keeping the spoon in the tumbler itself, what will happen? The spoon also will get heated. So you may forget and you will move, and when you come back and touch the spoon, it will be hot. Correct. That what is happening there? Conduction is happening there. Okay. Conduction takes place when two bodies of unequal temperatures are in contact with one another. There's a flow of energy from the warmer to the cooler body. Okay. From the warmer, the tumbler or the pan towards the cooler spoon, there is a movement of energy. That is how the conduction happens. I think it's very easy to understand. This transfer of heat actually continues until the two bodies attain same temperature. Or if it is contact is broken, it is over. If it is still in touch, if the spoon and the tumbler is together, until both the bodies have the same temperature, and the process will continue. Okay. That is how what is happening in conduction. So conduction is actually important in heating the lower layers of the atmosphere. That's about the conduction. Then we about the convection. Convection is actually air in contact with the earth rises vertically on heating in the form of currents. Okay. So vertical heating is called convection. Suppose this is Earth's surface. Vertical heating happening. This is called convection. Okay, so air in contact with the earth rises vertically on heating in the form of currents and further transmits the earth heat of the atmosphere. This process of vertical heating of the atmosphere is known as convection. Okay, the convective transfer of energy is confined only to the troposphere. So unfortunately, where it is limited only to troposphere of the atmosphere. It is not going to stratosphere, mesosphere or something. Okay, this is called convection. Now the last one, what is advection? Transfer of heat through horizontal movement of air is called advection. Horizontal movement of air is called advection. Okay, horizontal movement of air is actually important than vertical movement, because what happens? Horizontal movement means we move like this. It is more important than going up. So advection is more important, because what happens is that if this is Earth's surface and this area is hot and this area is cold, and this heat will be transferred from the hot to the cold area, and we'll try to balance the situation. So this is very important with regards to advection. Okay. This actually we can see in tropical regions where the heat is more. Northern India during summer season, local winds called Lu is there. Okay, there's a local wind called Lu. Okay, and this is actually an example of something called advection. That is horizontal movement of air is called, there is a wind, and this wind name is Lu. Okay, you can see in North India during summers. Okay, so these are the concepts which I want to explain. I will repeat again the concept of conduction, convection, advection. Don't get confused. What is conduction? Conduction takes place when two bodies of unequal temperatures are in contact with one another. There is a flow of energy from the warmer to the cooler body. Just give me a minute. So we are talking about conduction. Conduction means This takes place when two bodies of unequal temperatures are in contact with one another, and there's a flow of energy from warmer to the cooler body. Transfer of heat continues until this body attains same temperature, okay, or it is a contact is broken, and this situation is called convection. I told you example of the spoon and the tawa example I've given you. You should be knowing, okay. By this time I think the concept is clear with regards to conduction. Then it comes to convection. Convection means air is moving in a vertical way. It is going up, okay, vertical way. It is moving in a vertical thing, okay. Air in contact with the earth rises vertically on heating, okay. And actually, this act confined to only troposphere, okay, convection. Confined to only troposphere. Okay, the last one is convection. Convection is the transfer of heat through horizontal movement of air is called, last one is advection, I'm sorry. Last one is advection. It is horizontal movement of heat through movement of air is called advection. Horizontal movement of air is relatively more important than the vertical movement. I told you why. In middle latitudes, day and night variations are there, or some areas will be hot and some areas will be cold, and movement of or balancing situation is important with regards to advection. Advection is helping in balancing. And we have an example of Lu, the tropical regions, particularly in North India during summer season. Local winds are called Lu. It is the outcome of advection process. Okay. That's it I want to discuss today. Heat budget, it will not finish. We will take it tomorrow. If you have any doubt, you can ask. Sorry, yesterday I couldn't do this. Okay, then see you tomorrow. Bye.